I am Chad Barker, your Sudoku professor, and today I am helping Glen Emery with his puzzle. He sent this in. It's from his local newspaper. Difficulty rating was a 6-star puzzle. So this whole discussion would mean a lot more to you if you go down below and download the puzzle and work it yourself, and then either find the solution yourself, which would be something that would be very encouraging to you, I know, or you could come back to the video, or actually, whether you find the solution or not, you should come back to the video and see either your solution matches what I found, because maybe you found something different. If you do find something different, go ahead and post that down below. But again, watch the rest of the video, and I'll lead you through my solution. So pause the video, go down below, and download that. Okay, so I'm going to jump in here and show you what I found, and we'll go through the process, how I discovered it or whatever. So, my process. So after going through the 1 through 9s and doing a little bit of think outside the box, the simplest think outside the box, this is where I'm stuck at. Now, I haven't done a lot of extra think outside the box, obviously, at this point. We're just getting started with that. This puzzle is going to require a great deal of think outside the box, one way or the other. After this point, the think outside the box starts to get a little more difficult, simply because there is no row or column with less than, or with more than 4 numbers in the row or the column. So you're always dealing with at least 5 numbers, and in many cases you have 6 or possibly 7 numbers missing from the row or column, and that's going to be a problem, or it's going to be a difficulty, if you will. Okay, so I'm going to do this 2 ways. I'm going to first show you how you could have found this solution using the techniques that I teach in the senior level lessons. So it is solvable using senior level, but I'm going to show you that first. Then I'm going to show you how I actually found the puzzle, which is a little bit different. There's how I came across it. I kind of stumbled into it, if you will. But there is an actual process that you could have followed. So let me get into that process. The understanding at this point is that we were going to be doing a lot more think outside the box, and there are a number of rows, and let's see, I'm not sure if there's actually any columns. So yeah, so we're at a point where we would be taking the next step of think outside the box, looking at rows or columns where there were 5 missing numbers, because there are no rows or columns with fewer than that. So we'd be looking at row 1 as a think outside the box. We'd be looking at row, let's see here, this one, 4, 5, 6, and then we'd also look down here at row 8 and 9, right? Both of these. We could be doing think outside the box on these. There are no columns with less than that. And I can tell you that we would come up with a little bit more information if we did that. Specifically, we would realize, let's see here if I can look at some of my notes here, but it's really just a little bit more information. As a matter of fact, I think that the only thing of significance that we learn is that this here can only be 2 or 7. And every other space that we look at has at least 3 possibilities from this point, even though we've done that. There's no columns that we could do that have less than that 5 or less missing. So every column has at least 6 missing. And then we have these 2 rows 2 and 3 that are just horrible as well. So the question is, once we've done all that, think outside the box, and we're sitting there twiddling our thumbs trying to figure out what to do, is, which column do we go after? I mean, we could go after this row 3. That wouldn't hurt, but we've got all of these opportunities for columns. And I'm not going to do it all, because you could if you wanted to. We could go after column 2. We could go after this column. What's that? That's column 7. And then 8 and 9. And I guess, let's see here. Is there any other? Yeah, this column 4 here. All of those are the next stage, I'll go ahead and tick this one up here, even though we're not going to get to that. But these are all the next stage possible think outside the box. It's still a lot of work, but I want to focus on this column 7 here. All right. So what's missing is 2, 3, 5, 7, 8, and 9. And if we go back to, if you look at Senior 404. Senior 404 is a technique that I showed you how to examine the number of times each of those numbers shows up in the row or column, or in this case, just the column. And but I showed you in the snippet a contribution by Norman Cooper about how we could do a little shortcut and make that a lot easier. So if we actually look at each of these numbers, 2, 3, 4, 7, 8, and 9, say, well, how many times? Where can it go? Well, actually, at this point, there are no 2s on the board. There never were any 2s, so we still don't have any 2s. And so 2 probably can go in every space, so we're not going to even think about that. The 3, where can 3 go? Well, 3 is eliminated from these 2 spaces up here in rows 1 and 2. So it can go in 4 places. 5, okay, so 5 can't go here. It can go here. That's 1. It can go in it is eliminated from these 2 and this one up here. So 5 can only go in 2 places. So we underline 5. Let's see here. 7. So 7 can go here, 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 and here. 7 can go in, 5 places. 8 can go here, and that's 1. Can't go here and here. That's 2, 3. Can't go. I'm sorry. Can't go these 2, and here. So 8 can only go in 2 places. And then 9 can go. It can't go here. It goes here. Can't go here. Here. Can't go up here, so that's 2 places. So 5, 8, and 9 can each only go in 2 places. Now let's see whether they overlap. And what we discover is that 5 and 9 can only go here and here. Those are the only 2 places that 5 and 9 can go, which means that 8, which actually could go in those same, it goes here or here. Actually, so it's eliminated from this space here because we now have a 5-9 cross box double-double, and 8 then has to go here. Okay, so that right there, that one discovery is key, and I'm going to pick back up from that in just a minute and show you how we solve from that point. But I wanted to go over how I came across it because, I came across this a little bit differently rather than using this technique. And not because the technique is bad, it's just because of, I'll show you. I'll show you how it's just because I was doing other things before then. Okay, so what I did, and let me just go ahead and erase the 8 and the 5 and the 5, 9 up here so it doesn't confuse my next discussion, which is how I did it. So, I started doing Think Outside the Box, all of these Think Outside the Box that I could do with, where there's 4 numbers in the row or 5 numbers missing. And I know that Glen has done all of this, but I'm just going to go over how I did the process. So, I'm looking at this row here, 2, 3, 4, 7, 8, and I go down the row, along the row there, and I don't find much of anything. I come up to this one up here. I do 1, 2, 3, 5, and 9, and I'm looking, and I don't really see anything. There's nothing valuable there. I come up here to 2, 3, 4, 5, and 7. So I look at this space, and I realize, okay, so 5 is eliminated, so that still leaves 2, 3, 4, 7. I come over here, and I see that 4 and 5 are eliminated, so that's 2, 3, 7. And I start to think, that sounds familiar. And then I come over and realize that, when I was doing this column here, that, I did find that this was 2, 3, and these other 2 spaces were 2, 3, 7. So I thought, okay, well, I've got 2 spaces along this row that can only be 2, 3, and 7. So, well, maybe that's important. So I'm going to make a mental note about what can go in this space. And then I'm going to keep moving on. So then I go here, I'm looking at this one. let's see, and I see, okay, 5's eliminated from here, so that's 2, 3, 4, 7 still. This again, I know this is 2, 3, 7. This one right here, this can be everything, 2, 3, 4, 5, 7. And then over here, it looks like 3 and 7 are eliminated, so this is 2, 4, 5. Yeah, I'm not seeing much there. So then I move on to the next row, and let's see here. That's what's missing here is 2, 3, 4, 6, 7. So I look at this space here, and 3 and 6 are eliminated. So let's see, that's 2, 4, 7 here. And I look at this space, and 4 and 6 are eliminated. So that's 2, 3, 7. I think, wait a minute. Okay, so I've got 2, 3, 7 here, and I've got 2, 3, 7 here, and I have a 2, 3, 7. So I'm starting to pay attention to these spaces that I've got this common number or combination of numbers running. And then I look at this space here, and let's see here. It doesn't give me, there's still got too many things can go here, and I look at this space here and this space here, and I still got too many things. There's at least 3 numbers, but I'm not making any progress with that. And I continue on up here, and we have, in this we have 1, 2, 4, 6, 7. Now keep in mind that I did not know, and I'm going to go ahead and erase this real quick. I didn't know that that was 2 and 7 only at that point, but until I got all the way up here with the think outside the box. This space, 2, 3, 4, 6, 7, and only, no, 1, 2, 4, 6, 7. Only 6 is eliminated. That's 1, 2, 4, 7. I come over here, and I see that this is 1, 4, 6 is in the column, so then I know that this is 2 or 7. I say, wait a minute. This is when I start to notice. I'm starting to think, hey, okay, hold on. This can only be 2 and 7. And these two, I remember, can only be 2, 3, and 7, because I've been making these mental notes as I go along. And so now I have a 2, 3, 7 cross-box triple combo. So that's the first thing I noticed. So I came down here, and I didn't have all this stuff, so I hadn't gotten to that point. So I started to realize, hey, you know what? This is a 2, 3, 7 cross-box triple combo in these 3 spaces right here, here, and here. So what does that leave us with? Well, that leaves us with 5. Oops, let me go back to the blue. And that leaves us with 5, 8, and 9. So I started to look, and I realized that, okay, well, this can be, this space can be 5, 8, and 9. This space can be 5 and 9. And this space, oh, well, this space cannot be 5 and 9. So it has to be the 8. And then that leaves us with a 5, 9 cross-box double-double. So that's how I came across it. I kind of backed into it. So it doesn't, if you didn't see it one way, there is a way to see it the other way, just applying the techniques that I've taught you in the senior lessons. And it's helped out by Norman Cooper's underlining method of when you find any number that can only go in 2 places. Okay, so there we have the start of the solution. All right, so now since we never made much progress to begin with, it is actually, we have a good bit of work to do, and I'm going to go ahead and do that work right now. So so we have let's just finish out the 8. So the 8s actually give us, this 8 allows us to do a lot of other, actually finish the 8s is what I'm trying to say there. So 8 actually ends up having to go up here, and then 8 has to go here, and I think then we have all the 8s. So the real question is, once you have that, what do you do next? And this was it's a little bit obscure, I guess you could say. So at this point, we're looking around, we're saying, okay, if we go through the 1 through 9s, we can see this. It might not be so obvious having just filled in the 8s. But let's, again, focus on this box 9, and we're going to look at where can 3 go in the box. All right, so we have the 3 here, and we have a row eliminating 3, and we actually eliminated the 3 from this space with the 2, 3, 7, meaning that 3 has to go here and here. 2, 3, 7 cross box. So that leaves us in this box 9 with only one place for 3 to go, and that's right here. And that forces the 7 here, and now we can proceed along. So the 2 then has to go here or here, forming a 2, 4 double-double. And that makes me think, well, where can 2 go back over here? And it turns out that 2 can only go here. And we are now left with, I think, a 159 triple double in this box. So 5 can only go here and here. 1 can only go here and here, and that turns out to be row eliminating. And so this space here can only be 5 and 9. Let's see here. So we've got the 3, and we can narrow 3 down over here. I'm just going back and looking at what did we fill in. The 7 can't go here or here. That doesn't help us much. We've done all we can with the 8. The 2, how about the 2 and the 7? So let's go back up here. Actually, let's just look at this column here. We have, if we do a think outside the box now, I think we only have 1, 4, and 5 missing. 1, 2, 3, 4, 5, 6, 7, 8, 9. Yep, 1, 4, and 5 missing. And 1 and 5 are eliminated from here, so this has to be a 4. And then this space can only be 1 and 5. And that's allows us to then carry over. Where can 4 go over here? We filled in the 4, so what can we do with that? We look over here, and we see that 4 is eliminated from these 2 spaces. That leaves 4 in the corners, but this is now a double column elimination. So 4 can only go in the left and right columns in box 7, and 4 can only go in the left and right columns in box 4, so it has to go in the middle column right up here. So 4 goes there and there, and actually we can narrow 4 to 2 places here and here as well in box 3 because of the new 4 information. And let's see. Anything we can do with 4? No, 4 can go too many places in box 5. So what's next? We have here in box 6, let's see, we have 2 and 7. That goes here and here, right? This is 2, 3, 7 is what's missing. So we know that space can only be 2 and 7. Now, if we go back through 1 through 9s at this point, we would pick up another critical factor is that if we look at box 1, 9 is now column eliminating because of the 8. Or we can do that a couple different ways. We can go completely through the 1 through 9s, or we can look at any box where we filled in some number. If we have now filled in a number that we didn't have the first time we went through the 1 through 9s, then we should relook at that box to see if there's any information that we can gather from that. And because it narrows down where numbers can go, if nothing else. And it allows us to, again, do a column eliminating 9 in this box, which answers a whole lot of other things. So this can't be a 9. It has to be 5, which answers this triple double of 5, and then that forces the 9 to here and the 1 to here, which makes this a 5, and this is a 9. And then that leaves us with a lot of neat things to do. So we need a 1, which can go here or here in this box 7. 1, 2, 3, 4, 5. We need 6, 7, 8. And we need 9. So 9 actually 9 has to go here. 1 here, 3 here, 3 here, 3 here. Let's see here. Clean that up, and then where are we with our 3s? 3. We have still some missing here. Here, 3, 3. Yeah, we still have missing in boxes 2, 5, and 8. 3s are missing. Well, we have almost finished everything down here in boxes 7, 8, and 9. We now only have a 2, 7 double-double in box 6. 1 is now column eliminating. Well, it doesn't really matter. We have all the other ones. 1, we still need 2. No help with that. 3, we have the 4, 5, 6, and then we need 7. So 2 and 7 can still go in everything. All right, so actually let's look at this 1, 3, 9 here. So we take the 1, and then 1 has to go here. That forces 6 to here. That's going to be a huge help. 7 is then limited to these 2 spaces, which is going to do a double row elimination. So 7 also is limited. So middle and lower rows in this box, middle and lower rows in this box, that means it has to go in the top row of this box. So 7 can only go here or here. And what else? So we have the 6. Looking at our think outside the box, we have the 1. So we're only left with 2, 4, and 7, which I can adjust the 1 here. 2, 4, and 7. This can be 2, 4, 7. This here cannot be 7. So this is 2 or 4 only. 2 can go in all 3 spaces, though. It's the last 3 things in the column. So that's supposed to be a 2 with a down arrow. This would be a 9, 2, 2, 4, 9, right? 1, 2, 3, 4. We need 5. There is 6, 7, 8, and 9. So this is now a 5, 7 double, but we actually have the 5 over here. So 5 goes here, and 7 goes here. And then we're left with, what, 2 and 4 here. Only 2 things, because the last 2 things in the column. 1, 2, 3, 4, 5, and 6. So 5 can only go here and here. And 6 can only go here and here. And 2 can go everywhere, and 4 is only eliminated from this space. So let's take a look at this think outside the box. We got the 3 and the 4, so we're left with 2, 6, 7. And this can only be 2 or 6. We got the 2, 7 here, and this is still 2, 6, 7. Looking at this think outside the box, we've got the 3, so we're left with 2, 4, 5, 7, and 4, 5. So this can only be 2 or 7 now. And this space here cannot be 5, so this is, and what do I have, 9 in there? Why do I have 9 in there? That has to be a 9. Oh, I'm sorry. So I messed this up from the beginning. I was copying from my notes. This should have been a 9 filled in rather than a 9 pencil mark, and I just went brain dead when I did that. Okay, so that has always been filled in as a 9. In case you were wondering, I apologize. Okay, so let's get back to this. So we've got 2, 3, 4, 5, 7, and this space here is still a lot of things, and yeah, so we've done what we can there. Now we want to look at this space. Let's relook at this column. Actually, you know, we've got the 2, 3, 7. We know that 3 can't go here. This is 2, 7. This can't be a 7. This is 2, 3, but we have the 7 over here, and so 7 is now limited to here or here. And so this space can only be 2 or 3. And so a couple different ways we could have figured this. If we had filled in the 7, we could have seen that it was a double column elimination, and then basically come to the conclusion that 7 has to go here. Or the way we just did it, which is to see the 2, 3 crossbox double. All right, so then 7 has to go here, and then 2 goes here. That makes this a 2, 7, 4, and 1, 1, 6. This then has to be 3, right? 3 can't go anywhere else. So 3 goes here. And 4 goes up here. And 9 here. And 2. I guess I could have filled in the 9 a long time ago. I didn't even see that over there when I was doing that. So okay, so then this is a 2 here. And this is a 2, which makes this a 4. And now this has to be a 2, which makes this a 6 and a 5 and a 5 and a 3 and a 3 and a 2. and we're all the way down to the end. We could finish this down here, 4 here and 2 here. What do we have left in this box? 1, 2, 3, 4, 5, 6, 7, 8, 9. 4 and 6, we have it over here. So 4 here and 6 here. That gives us 4 here and 7 here. And that this is, what, a 6, 7? Or no, let's see, we got the 6. 1, 2, 2, 7. So 2 over here and 7 right here. And I think that does it. Again, I apologize about the 9 here. I know that was probably confusing. Okay, so that was definitely a tough puzzle, but not a graduate level puzzle. And so thanks, Glenn, for sending that in, and I really hope that helps you. And if you have a different solution or anything else that you want to add, just comment down below. I really appreciate the comments. When you put the comments down below, what happens is that everybody gets to see it. A lot of times people will comment by sending something through the professor's direct line, and then I'm the only one that gets to see it, and it becomes difficult for me to share that with everybody because I really want it to come from you. So go ahead and comment down below whatever your solution was or anything else that you got out of this. And thanks a lot, Glenn. We'll see you next time. Hey, if you like that lesson and you want more like it, you may want to check out the Sudoku Professor's Insiders Club, where you get access to lots of great resources, solving tips and strategies, our exclusive puzzle library, a fantastic community of like-minded Sudoku enthusiasts, and much, much more. There's a link in the description down below. I'm Chad Barker, your Sudoku professor, and I'll see you in class.